Let's start with recursion. Before starting recursion, I think you have a profound knowledge on function in Python. Now look, what is a recursion? Recursion refers to a programming technique in which a function calls itself either directly or indirectly, and the corresponding function is called a recursive function. So look at this segment of definition: function call itself either directly or indirectly. So whenever a function call itself, we call this technique as recursion. Now, classification of recursion. When a function call itself directly from within its body, it is called direct recursion. Let me show you an example. Suppose this is a function written as def a, first bracket, open, close. Now from within the body of this function a, this function a has been called. The function call itself. That means the control will again move back to the function declaration line. From there again it will enter into the function. So from within the body it will again call the same function. So this is a continuous process and it will never end. Since the function is calling itself, that is why it is called direct recursion. Now let me show you another version of recursion. Look at this definition. Recursion can be indirect also. If a function calls another function which calls its caller function from within its body, it is called an indirect recursion. Look at the example below. Suppose we have a two function a and b written as def capital A, first bracket, open, close, and next look def capital B, first bracket, open, close. From within the body of the function a, look, the b function has been called, and from within the body of the function b, a is called. So from a, when b is called, look what happened, the control will move to the b function, and from within b, a is called, so the control again will move back to a. Again from a, it will call b, and again from b, it will call a. This time also the process will never end. It is in an infinite loop. In other words, we can say that the control is switching between a and b. Since none of the function is calling itself, that's why we are calling indirect recursion. Next, recursive function has at least two cases: recursive case and the base case. Let me tell you about the recursive case first. This is also called the inductive case. Is the more general case of the problem we are trying to solve using recursive call to some function. That's mean by keep on calling the same function again and again, we can find our result. But after some time, it needs to stop the recursive procedure or the recursive call. So for that we require a base case, or you can say it is a stopping case. It is a condition where a recursive function does not invoke itself. So each and every recursive function require a base case to stop the continuous recursive calls, because recursive call is infinite. So for that you have to write a condition within the function so that when it encounters a particular situation or a specific situation, the base case will be executed and it will stop the recursive call. Difference between iteration and recursion. So I will explain it by using an example or an exercise. So for that, let me take this exercise program to find the factorial of any number. It's a very easy. I think you have a knowledge of factorials. Factorial is the product of all the integers between 1 and the given number, including both 1 and the number itself. That's mean the factorial of 3 means 1 multiplied 2 multiplied 3. If you did for a loop, that's mean you have done the program on factorial. At first, let me show you the iterative function of factorial of any number. So look, this is the iterative function for the factorial. So here this function FACT, this is the name of the function. It is accepting a number within the variable n. Now f is initialized with 1 because the product will be stored within f variable. If we initialize f with 0, then the product will become 0 for each cases. Here I have taken 3 as example. From the main code we are calling the fact function and the parameter is 3. So this 3 will be initialized within this n variable and f is initialized with 1. So what the for loop is doing, for will be executed from 1 to n plus 1. That's mean you can say 1 to 4. In other words, you can say that the value of I will range from 1 to 3. Now the initial value of I is 1. By taking I equal to 1, it will enter into the loop. So there is a line f equal to f into I. So the initial value of f is 1. So 1 will be multiplied with the present value of I, that is 1. 1 multiply 1. So the result will be stored back into the variable f. Next, the value of I will be 2. Then this 2 will be multiplied with the present value of f, that is 1. 1 multiplied 2 is 2, and that will be stored within f. Now at last the value of I will be 3. So by taking I equal to 3, it will enter into the loop. This 3 will be multiplied with the present value of f. The present value of f is 2. So 3 multiplied 2 will be 6, and that 6 will be stored back into the variable f. Now the for I loop will complete this execution and it will come out from the loop. Now the function will return the present value of f, that is 6. So this 6 will be returned back to the main code. So in place of fact 3, we will get 6, which is the factorial of 3. So this is what the iteration process do. Now let me show you the same procedure in a different angle or in a different view. Look at the right hand side. Here we are going to find the factorial of n. So what it is doing? We are multiplying all the integers in between 1 and n. Both 1 and n are inclusive. For example, suppose we are going to find out the factorial of 3. That means we are multiplying all the integers numbers between 3 to 1. Or in other words, you can say we are multiplying all the integers between 1 and 3. Both 1 and 3 will be inclusive. That means we are multiplying n multiply n minus 1. Look what happened in case of 3. So n is 3. So here I have written 3 in place of n. And next n minus 1, that is 3 minus 1. 3 minus 1 means 2. Then n minus 2, that is 3 minus 2 means 1. We will stop here because the value becomes 1. So finding the factorial of 3 means we are multiplying all the integers from 3 onward up to 1. That is 3 multiply 2 multiply 1, which gives a result 6. Let me show you the same procedure in different view. Look at these steps. Look, finding factorial 3 means it is 3 multiply factorial of 3 minus 1. So here we need to find the factorial of n minus 1. That is 3 minus 1 means 2. So 3 will be multiplied with the factorial of 2. So in the next step, let me find out the factorial of 2. So for f2 equal to, it will be the same procedure. That means 2 will be multiplied with the factorial of 2 minus 1. 2 minus 1 means 1. That is 2 multiply factorial of 1. So what is the factorial of 1? Let me find out in the next step. So f1 equal to 1 multiply f of 1 minus 1. 1 minus 1 means 0. So the factorial of 0 will be multiplied with 1. So here we need to know the factorial of 0. What is the value of factorial of 0? Now look, we know that factorial of 0 is 1. If you don't have any idea regarding this, please go and check in the internet. So the factorial of 0 is 1. So in all the previous state, we did n multiply f of n minus 1. Here the value of n is 3. Look, the process is like this, n multiply f n minus 1. In the second state, the n is equal to 2. So I have written n multiply f of n minus 1. So in the third state, here the n is 1. So the expression will be look like this, n multiply f of n minus 1. So every state we have done n multiply f of n minus 1. And at the last state, when the value of n becomes 0, we conclude that its value is 1. Now we can replace this f0 in the previous state by 1. So this will be replaced by 1 because now we have the value for f0, that is 1. So this 1 will be multiplied with this 1. So the result will be 1. That means the value of f1 is 1. Now this 1 will replace this f1 with 1. Since in the below step we got f1 equal to 1, so we replace f1 with 1. Now 1 multiply 2, the result is 2. That means f2 is equal to 2. So this 2 will replace f2 in the previous state. So this will be replaced with 2. So 2 multiply 3 is 6. That means the value of f3 is 6. So what we are doing, let me summarize. So we are finding f of n equal to n multiply f of n minus 1. So in every state we are performing the same operation, that is n multiply f of n minus 1. So the same function is called repeatedly with the decrement value of n, and when n becomes 0, it returns 1 to the previous state. and by doing backtracking we get the result at the beginning of the function or from where we have started. So the state from where we are going backward is called the base condition, that is f0 equal to 1. This is the base condition. That means within the function when n becomes 0, it has some specific values for f of n. So it is returning that specific result to the previous state. And after doing the pending work, it is finding out the value for f1, and the value of f1 is again returning back to the previous state. So by using the value of f1, it completes its pending work and it is getting the value for f2. So this value for f2 is again returned back to the previous state. So in the previous state, the value of f2 is used to find out the value of f3. I think that you have understand that there is a concept of state. Now let me show you how to implement this method within a program. First of all, let me define a function, say def, and let me write down the name of the function as fsct, and within the parameter there will be a single variable, say n. So it is accepting a single argument, and within this body, look, when n becomes 0, so let's write like this: if n equal to 0, it will return 1. Else, if it is other than 0, it will return n multiply fact of n minus 1. Look, I have written this statement in the else part. N multiply the function name and within parameter n minus 1. So whenever the value of n is other than 0, it will keep on multiplying n with fact of n minus 1. So this is the recursive call. That means it will call the same function fact with different value, that is n minus 1. That means n will be decremented at each call, and for each call it will create different state within the primary memory. I will show that state diagram separately. So first of all, look at the program. Now from within the main code, let's call the fact function with the value 3. That means we want to see the factorial of 3. Let's run the program. Look at the output. This is 6. Now you want to find the factorial of 4. So what happened? It will give 24. So this is the program of a recursion. In a recursion, the function call itself and it stop calling when it founds n equal to 0. This is called the base condition, and the else part is called the recursive condition. The call is called the recursive call and the process is called the recursion. Let me show you the state diagram, then it will be more clear to you. State diagram of factorial of any number using recursion. I keep the program on recursion on the left hand side for our reference. I have written the complete name of the function as factorial, and the rest of the codes are similar. So look what it is doing. From the main code, it is calling factorial of 3. Let me show you like this. Within the box, suppose this is a state and this is the initial state, that is the state of the main function. So from within the main function, it is calling the factorial 3. So what it is happening, it is calling this factorial function and it look like this. Look, the name of the function is factorial and it has an argument n. So within n, it is accepting the value what it is sending from the main code, that is 3. So n is here, n is initialized with 3. Now in this case, n is not equal to 0. Look at the program in the left hand side. If n is equal to 0, then it will return 1. But in this case, n is not equal to 0. So the else part will be executed. So what is written within the else part? Return n multiply factorial n minus 1. That means we can write it will be 3 multiply factorial n minus 1, that is 3 minus 1. So this will be 2. So the same factorial function is called with a different value or the decremented value, that is 2. Now look at the next state. So in the next state, again the function has been called, and this time the value of n is 2 because it is sending this 2 to the next state. And now this n is accepting the value 2. But one thing, keep it in your mind that creating state means you are creating the photocopy of the same function, but the value of n are different in every state. You can think that this n the n of the first state is completely different from the n of the second state. They are completely different variable, though their name are identical. And all these states are occurring in different memory area within the primary memory. So now again, here the value of n is 2 in the second state. So this time also n is not equal to 0. So else part will be executed. Else part means return n multiply factorial n minus 1. That is, here the n is 2. So return 2 multiply factorial n minus 1. That is 2 minus 1, which will be 1. Again, there is a recursive call. It is calling the same function with the value 1. Look what happens in the next state. The variable n is accepting the value 1. So this time the value of n is 1. This time also it will execute the else part because n is not equal to 0. So it will return n multiply factorial n minus 1. That is 1 multiply factorial 1 minus 1 means 0. Again, there is a recursive call. So look at the next state. In the next state, the factorial function, it will receive 0 as the value for n. This time the value of n is 0. Now since if n equal to 0, it will return 1. So what happens? So when it encounters the base condition, that is n equal to 0, it will return simply 1. Where it will return? It will return to the previous state, or you can say it will return the result from where this state has been called. That means this one will be returned to the previous state over here. So factorial 0 will be replaced by 1. Think like this. So this 1 will be multiplied with 1. So this is the pending work in this state. So now we got the result, that is the factorial of 0 means 1. 1 multiply 1 means 1. So it will return the product 1 to the previous state, means over here. So 1 will be written back over here. So 1 multiplied 2, the result will be 2. This will be again sent back to the previous state. So this will be replaced by 2. Again 2 multiplied 3 is 6. This 6 will be again returned back to the previous states, that is over here. So within the main, when we print factorial of 3, we will get this 6 as a final result. In case of iteration, less number variables are required. But in case of recursion, different states are forming in different memory area, and for that, a number of variables are generated in each and every state. In this example, only one variable has been defined within this function. So for fourth state, it generates 4 variables. If the function contains 5 variables, and for 10 states, it will generate 10 multiply 5, that is 50 variable within the memory. So recursion occupies more area within the primary memory than the iteration. In other words, we can say that recursion consumes more time and space. You can say that this is the head of the recursion and this is the tail of the recursion. The last state is called the tail of the recursion. Since the result is forming at the head of the recursion, we can say this procedure as non-tail recursion. Whenever we get the result at the tail, we will say that this is a tail recursion. If the result generated at the head of the recursion procedure, then we will call it as a non-tail recursion. So the technique that I have shown you is a non-tail recursion. That means you have understood that there is a possibility of getting the same result at the tail of the recursion, and that time we will say that that is a tail recursion. I will show you an example for that also. So what is a tail recursion? A recursive function is said to be tail recursive if the recursive call is the last thing done by the function. There is no need to keep record of the previous state. To explain this, let me move back to the previous slide. Look at this state. This recursive call is not the last thing in the function. So when this factorial true receives the result, it will then multiplied with 3. So each and every state there is a pending work, and the recursive call is not the last thing to do. So in each and every state, after getting the value for the corresponding factorial function, we have to multiply that with the respective value of n in each state. So when the program is backtracking, it is performing the pending work. That means it has more things to do. And this way, at the beginning of the recursion, we are getting the result. But think, when this recursive call is the last thing or the last statement of the factorial function, then we will call it as a tail recursion. So that's why I have written this definition. Again, I am repeating, a recursive function is said to be tail recursive if the recursive call is the last thing done by the function. There is no need to keep record of the previous state. For that, let me show you an example. The same example of factorial. Look, in this case, I have written the factorial function with different coding. Look, it accepts two parameters n and a. This n will receive the value for which the factorial is going to be calculated, and a is the variable which will receive the starting integer value for generating factorial of n. So the starting value for any factorial is always 1. So look at the main code. I call the factorial function with a value 3, 1. That's mean we are going to find out the factorial of 3. The factorial of 3 means 1 multiplied 2 multiplied 3. So 1 is the starting value. So I have written 1. So 1 will be passed to a and 3 will be passed to n. Now if the value of n is equal to 0, it will return a. So this is the base condition. And what is the recursive case? Look at the else part. This time I have written return factorial within bracket the decremented value for n, that is n minus 1, and the product of n and a, that is n multiply a. Now look at the state diagram, what it is doing. So from the main code, it is calling the factorial function. So after calling this function, look what happens. The function factorial receives two values for n and a, that is 3 is initialized within n and 1 is initialized within a, because 3 and 1 has been passed to this function factorial. So this time n is not equal to 0, so it will move to the else part, that is the recursive case. And here it is performing n minus a. It will call the factorial function, the same function, and this is called a recursive call, and the parameter is n minus a comma n multiply a. N minus a means here the n is 3, so 3 minus 1 means 2, and n multiply a means 3 multiply 1, that is 3. Now again there is a recursive call. Look at this next state. So this time the function factorial will receive 2 and 3 for n and a respectively. So 2 will come within n and 3 will come within a. This time also n is not equal to 0, so it will execute the else part, that is factorial n minus 1 comma n multiply a. N minus 1 means 2 minus 1, that is 1, and n multiply a means 6. Next state. So again there is a recursive call within the factorial function. 1 and 6 is stored within n and a respectively. Now again the value of n is not equal to 0, so it will call the factorial function again with a value n minus 1. N minus 1 means 1 minus 1, that is 0, and it will send the next parameter as n multiply a, that is 1 multiply 6, and the result is 6. Now look at the last state. This time when the factorial, the same function is called, 0 and 6 has been passed to the next state. So n receive the value 0 and a receive the value 6. This time the value of n is 0, so it will return the value a. Look at the value of for a, this is 6, and this 6 is the factorial of 3. That's mean the result has been generated at the tail of the function, and that is why it is called tail recursion. Now this 6 will be pushed back to the previous function, so this will be replaced by 6. So no pending work is over here. It will simply push the result back to the previous state. So you can think that again this function will be replaced by the value 6. Here also nothing to do. It will just simply return the result back to the previous state. And finally this 6 will be returned to the main function, and within the main function this portion of this code will be replaced by the value 6. Again I am repeating, since we are getting the result at the end of the recursive state or at the tail of the recursion, that is why it is called tail recursion. I think you have noticed that the intermediate state are doing nothing but push back the result back to the main. So after getting the result at the end of the state, we can ignore the intermediate state and we can directly push the result back to the main directly. Now, advantage of recursion. Recursive function make the code look clean and elegant. A complex task can be broken down into simpler subproblem using recursion. Sequence generation is easier with recursion than using some nested iteration. Disadvantage. Sometimes the logic behind recursion is hard to follow through. Recursive call are expensive, inefficient, as they take up a lot of memory and time. Recursive functions are hard to debug. Let me do an exercise for you. Program to find the sum of the digits of a given number. Hope you are familiar with this program. If you don't, no problem. I am showing you the iterative process first. Let me take the number n as say 123, and let's take a variable s which is initialized with 0. It will store the sum of the digits, that is 1 plus 2 plus 3. Now while n greater than 0, we will do the following operation. Let us take or extract digits from the right hand side. So for that I have to write n mod 10. N mod 10 means when this the given number n is divided by 10, the remainder will be 3. So this process will extract digits from right hand side. Now the next operation will be s equal to s plus r. So the extracted digit will be sum up with the variable s, and the sum will be stored within s. Next, let's do an integer division n /10. That's mean when n is divided by 10, the quotient will be initialized within n. Now after coming out from the while loop, if I print s, so we will get the sum of the digits. Now if you forget the procedure, let me show you a dry run. The value of n is 123. Now n is greater than 0. So the first operation within the while loop is n mod 10. That's mean initially the r will be 3. So 123 mod 10, it will extract the last digit. It will find out the remainder. So when 123 divided by 10, the remainder is 3. Now these 3 will be sum up with s. The initial value of s is 0, so 0 plus 3, it will be 3. Now 123 divided by 10, this is an integer division. It will find out the quotient. So when 123 is divided by 10, the quotient is 12. Now the n becomes 12. Again, let's move back to the while loop. So now the present value of n is 12. 12 greater than 0, yes. So 12 mod 10, this time r will be 2. And again s equal to s plus r means the right hand side will be executed first. The present value of s is 3. So 3 plus the present value of r is 2. 3 plus 2 is 5. So 5 will be stored within s. So this s now will become 5. Next, n equal to n divided by 10. The present value of n is 12. 12 divided by 10. The quotient is 1. Now again the while loop will execute. This time the value of n is 1. 1 greater than 0. Yes. Enter into the loop. Now 1 mod 10. When 1 is divided by 10, the remainder will be 1. Now the present value of s is 5. So 5 plus r, this time r is 1, 5 plus 1, 6. So 6 will be stored within s. Now the present value of n is 1. 1 divided by 10, the quotient will be 0. So n will become 0. Again move to the while loop. This time the value of n is 0. 0 greater than 0? No. The condition becomes false. Then it will come out from the while loop. Then when we print s, it will print the value, that is the present value of s, which is 6. So it will give 6, which is the sum of all the digits of the given number 123. By looking into this iterative process, let me write down the recursive process. Look very carefully. We are finding the remainder and we are keep on add this remainder with the variable s. So this operation is going on until n becomes 0. So as long as n is greater than 0, it will continue this operation and finding out the sum of the digits. So you can think the recursive procedure as like this. If n is equal to 0, it will return 0, else it will return n mod 10 plus sum of the digit n/10. So before explaining, let me write down the program first. Sum of the digits using recursion. So first of all, define the function. Say the name is sum of the digits. Let me write in short SOD, and it accepts a parameter n. Within this, let me write down like this. If n equal to 0, it will return 0, else it will return n mod 10. That's mean it will extract the digit one by one from the right hand side, and again we have to call the same function with n/10. Next, within the main code, let me call the function SOD. Say suppose I'm passing the parameter as 123. Look what it gives in the output. Look, the output is 6. That is the sum of the digit 1 plus 2 plus 3. So let me write down like this: sum of the digits equal to, that's mean the program is working correctly. Let me show you the dry run or the state diagram. So from main we call the function SOD with the value 123. It will pass this number to the function where n will be initialized with 123. Since it is not equal to 0, so else part will be executed. So in the else part, it will return n mod 10, that's mean 123 mod 10, which will be 3, plus again it will recursively call the same function SOD with n/10, means 123/10 means that is 12. So this is happening in the first function call. Now within this function call, again the same function has been called recursively. So this time it is sending 12 to the next state. That's mean in the next state the value of n will be 12. Here also n is not equal to 0, so again it will return n mod 10, that is 12 mod 10 means 2, plus again there is a recursive call SOD with n/10 means 12/10. So when 12 is divided by 10, the quotient is 1. So from this state the SOD function is again called recursively. This time it will send the value 1 and n will be initialized with 1. This time also n is not equal to 0. So the segment under the else part will execute. That's mean again it will return n mod 10, that is 1 mod 10. So when 1 is divided by 10, the remainder will be 1. Then plus again SOD function will be called with n/10, 1/10. So when 1 is divided by 10, the quotient will be 0. Now from this state there will be a recursive call. This time 0 is passed to the next state. So in the next state the value of n is 0. Now in this state n is equal to 0 and this if condition satisfies. So it will return 0 from here. Now this 0 will be returned back to the previous state. That's mean SOD 0 will be replaced by 0. In this state the pending work will be evaluated, that is 0 plus 1, which will be 1, and that 1 will be returned to the previous state, that is over here. So this will be replaced with 1. Now 1 plus 2, 3, and 3 will be returned to the previous state, that is over here. So this will be replaced by 3. So 3 plus 3, 6 will be returned to the previous states, that is the beginning of the program or within the main code. So this will be replaced by 6. Some recursion exercise for you. Calculate the sum of number from 1 to n. Find the sum of element in a list. Consider that a list contains all integer number and find the sum of without using any library function. Next, convert a decimal number to binary form. Write a recursive function to reverse a string. And the last one, anagram. Anagram are words made up of all the characters present in the original word by rearranging the characters. Example, anagram of the word TOPR, TOP, TPO, OPT, OTP, PTO and POT. All combinations of character within the word. So write a program to accept a word from user and generate all anagrams. So this is all for this video. If you have any problem, feel free to write me. Thank you.